Hey Tube, welcome back. Redundancy. What is it and where it used? So redundancy refers to the practice of duplicating critical components or systems to improve reliability, availability, and fault tolerance. It involves adding extra resources or backups so that if one component fails, the redundant component or system can take over, ensuring that the overall system continues functioning without interruption. In the context of computing, networking, and data centers and system design, redundancy is a key strategy to prevent single points of failure and improve the system resilience. So, let's talk about the types of redundancy. There are mainly four types or five types. We start to talk them about them one by one. The first one will be the uh, hardware redundancy. Let's make it with R here. So this is the first one. The hardware redundancy involves duplicating physical components such as servers, storage devices, power supplies, and network equipment. An example for that, like using multiple power suppliers in a server. If one power supply fails, the other continues to provide power, ensuring the server remains operational. Number two, there is software redundancy involves running multiple instances of the same software or service across different machines or environments to ensure continuous service. And I would say the software redundancy is not that only, it's pretty has a lot of details in it, but if we are talking on a high level, this is where we talk about. Um, an example for that, we can run multiple instances of a web server behind the load balancer. If one instance fail, the others can take over, or the other can handle the load. Number three, network redundancy. So it involves duplicating network components such as routers, switches, and internet connections to prevent network failures. An example for that is like having multiple internet service providers like ISPs as ISP for an organization. So if one internet service provider fails, traffic can be routed through the others. Number three, there is data redundancy. So it involves duplicating data to ensure its availability in case of hardware failures or data corruption. An example for that, we can use like data replication across multiple database servers or storage locations, to ensuring that data is available even if one storage device fails. Lastly, geographic geo geographic redundancy. So it involves replicating systems and data across multiple geographic locations like data centers or cloud regions to ensure resilience in case of regional outages or disasters. An example for that, we can just deploying a web application across multiple regions in a cloud platform like AWS or Google Cloud, so that if one region goes down, the application is still available from other regions. Okay, now we need to ask another question. Why? Why redundancy is important? Let's try to answer this one by one. The first one, I would say, sorry. Not why, not why. Let me delete this. We will answer the why in a bit, but we need to answer the where. Where redundancy is used. Right now, we did talk about what is redundancy and we talk about what are the different types of redundancy. Now we need to talk about where redundancy is used. The first thing, it will be the data centers. It is used in data centers. Data centers employ redundancy in power suppliers like dual power feeds, backup generators, network connections, and cooling systems to ensure high availability. And the key use cases of that, like if the primary power grid fails, backup generators ensure that servers remain powered on. And number two, we use like redundancy in cloud infrastructure. Infra. So cloud providers like AWS, Google Cloud offer built-in redundancy through services like a multi-region deployment and availability zones, ensuring that applications remain available even during hardware or regional failures. A use case for that, it's just like hosting a web application across multiple availability zones so that if one zone experiences an outage, the app is still accessible from the other zones. Number three, networking. So redundancy is common in network architecture where multiple network paths like routers, switches, cables are provided to ensure that data can still travel between nodes even if one path fails. Use case for that, like using redundant routers and switches in an enterprise network to maintain connectivity and remain it connected if one device is failed. Number four, also it's used in storage system. Redundancy is used in storage system to protect against data loss, like techniques for that, which is redundant array or independent disks, data replications, and backup systems ensure that data is not lost even if a storage device fails. A use case for that, just we can use mirroring duplicates data across two disks. If one disk fails, the data is still available in the other. Number five, it's used in the database systems. So database systems often use redundancy through replication and clustering. In replication, data is copied across multiple database nodes. In clustering, multiple database servers act as a single unit to handle requests, ensuring that if one server fails, the other can continue processing. A use case for that in an e-commerce platform, the database is replicated across multiple instances to ensure that user data and orders remain available in case of server failure. There are other things that be used in, like it's I would say in the CDN also. CDNs use geographic redundancy by caching copies of content in multiple locations, like edge servers. This ensures that content is available even if some servers goes down, and it reduces latency by serving users from the nearest available server. A use case for that, a streaming service like Netflix delivers videos content from the closest CDN server. If one server fails, the others take over. Okay, let's talk about the why. Why do we need redundancy? The first thing, it will be the increased availability. It's all about availability. increased availability. Redundancy ensures that systems remain operational even when component fails, improving overall availability and uptime. Also, we need it for fault tolerance. By having multiple components perform the same task, the system can tolerate the failures of one or more components without impacting the overall service. Also, it's great in disaster recovery. So, geographic redundancy, for example, allows systems to continue operating even in the case of regional disaster like earthquakes, floods, or power outages. Also, it's great in reduced downtime because redundant component can seamlessly take over in case of failure, reducing or eliminating system downtime. There are some challenges though come with redundancy. One of them will be the cost because we're using multiple components. Because implementing redundancy increases the hardware, software, and operational costs because additional resources are required to provide the backup capacity. And number two, which come with redundancy, which is the complexity. Managing redundant systems can be quite complex, especially when dealing with failover mechanisms, data replication, and synchronizations across a distributed system. Also, we can introduce some inefficiency. Efficiency. Some redundant components may remain idle or underutilized until a failure occurs, leading to inefficient use of resources. Also, there is lastly a problem in data consistency. So, in case where data is replicated across multiple nodes or data centers, ensuring data consistency and synchronization can be challenging, especially in distributed systems. So, in conclusion, redundancy is critical design principle used in systems to ensure reliability, fault tolerance, and high availability. By duplicating key components, whether hardware, software, or network infrastructure, redundancy minimizes the risk of system downtime due to failures. It is widely used in data centers, cloud services, networking, and storage to provide continuous service, improve disaster recovery, and prevent single point of failure. However, redundancy must be balanced with cost, complexity, and efficiency considerations. So that's it for this video, and see you in the future.